Okay, we're on Unit 5, Lesson 4. The sum of a sequence. There's sum of an arithmetic and geometric sequences and series. So one formula is given to you on the Regents exam. The other one I'll let you write in for our Unit 5 test. So you have the definition for the sum. Very rarely do we see it on the Regents, but I will cover it just so you have it in the slim chance that it actually is on there. So we already saw the summation notation, okay, which is like your E, the summation notation, and the starting point and the ending value. So if we want to find the sum of an arithmetic sequence, remember the summation is arithmetic because you're adding each term. Our A1 is identified as -2, and then we have our AN, which is AN minus 1 plus 5. Remember, the N minus 1 is the previous term. So if I'm going from 1 to 5, that means I already have 1. I need 2, 3, 4, and 5. So to find 2, that means I'm taking previous term plus 5, which is 3. Then I'm taking previous term plus 5, which is 8, previous term plus 5, which is 13, and then previous term plus 5, which is 18. So those are your values. Now, since you want to find the sum of that, and it's denoted by the sum of 5, sum of base 5, that just means that it's the sum of the first 5 terms of the sequence. So I add these numbers together plus the -2. Don't forget the -2, and that gives you a total of 40. Now, where this actually comes from is what is known as rainbow addition. Okay, it's going to give us a little formula here. So we have our definition of a arithmetic sequence. All right, and the numbers are shown below: 3, 5, 7, 9, 11, 13, 15, and 17. And what they did is they paired them off, the first and the last, the second to the last, and so on and so forth. And each paired sum is 20. Now, how does each paired sum equal 20? It's because if I go from 3 to 5, I'm adding 2. If I go from 17 to 15, I am subtracting 2. So they balance each other out. Okay? So that's what you would put. You would put your own explanation of that, and it's a balance because you're adding and subtracting the same amount. And that's what will happen in your arithmetic sequence. Remember, it's always adding the same amount or subtracting the same amount as you go up. How many pairs are there? 1, 2, 3. There are 4 pairs in this example. And then we want to use our answers to find the sum. Well, there's 4 pairs, so there's 4 pairs, and it's 20 for each pair. So that gives you a total of 80. And if we're looking to create a formula, so if we're looking to create a formula here, we have our first term, okay, plus our last term, which is n. So the first term plus the last term, and then it's going to be, it would include the second to the last, the third to the last, and so on and so forth. And what we would have to multiply this by is your n minus 2. So this 20 up here was your A1 plus AN. That's how you got the 20. N minus 2 is because there's 2, 4, 6, 8 terms here, but there's 4 pairs. So that's where the n over 2 comes from. And then you have the sum of n. N represents however many terms there are in the sequence. And this would be in parentheses because you're doing that first and then multiplying by the n divided by 2. Okay? So there's your formula. This is the formula you will be able to add to your sheet that we have from the Regents exam. So we're able to put that right on the bottom and use that on any test and quiz. Okay? Now, in exercise 3, trying to use the application of this formula. So which of the following is the sum of the first 100 natural numbers? Now, natural numbers are counting numbers. So counting numbers, you start counting 1, 2, 3, 4, and so on and so forth. So the sum would be 1 plus 2 plus 3 all the way to 100. So if you want to go ahead and put all those in your calculator, be my guest. It will take you a little while. You might make an error. So that's why we want to use the formula instead. So we have our S of n. In this case, n will be 100. 100 over 2, and then a1 plus an. So you would have 50 times 101, which gives you 50/50, which is choice 4. And that's just using the direct application of the formula. Now, find the sum of each arithmetic series described or shown below. So part A, you have a1 and an. So you have that part of the formula. Now it tells you 16 terms. If it didn't, you would have to figure out what it is going up by or down by, and then find out how many terms are missing between the -2 and the 46. So luckily they gave us the 16. So S of n is 16 over 2, and then you have -10, which is the first term, plus 50, which is the last term, so that gives you 40, and you multiply it by the 8, and you get 320. In letter B, okay, what we have here is the first term is -8, and their difference is 6. There are 20 terms. So we have our A1, we have our N, because there's 20 terms. Now, the only thing we're missing is A20. So A20, remember your formula from a couple sections ago. It's A1 plus N minus 1 times D. So A1 is -8 plus N minus 1, which is 20 minus 1, and then D is 6. So you would put that in your calculator, however you want to do it, 19 times 6, and then subtract 8, and you would get 106, and that would be your A20. So when you plug into your formula for the sum, you have S of n equals 20 over 2, and A1 is -8, plus 106, which is AN, and again, put that in your calculator, and you get 980 is the sum of those 20 terms. Okay. In letter C, now they gave me A12, so their difference is -3, and I need to find A1. So A12 is -29, A1 plus, I'm just going to put 11 in here because that's 12 minus 1, and that is times -29. Okay, so you have to multiply the 11 times the -29, and, oh, sorry, not -29, it's a -3, because that's the difference. All right, don't be all mad at me. So you have 11 times the -3, and then you have to bring that over, that's your -33, add it to both sides, A1 is 4. Okay, so now you go ahead to your sum, and it's S of 12, so 12 divided by 2, A1 is 4, plus a -29 for your A12 in this case, multiply them, and you end up getting a -150. So you can have positive values, you can have negative values, you can have fractions, it doesn't matter. Okay, letter D, the last one here, is we have the sum. So this is one of the ones where we have to determine how many terms are in the sequence. So we know our A1 is 5. And now you want to find your D. Okay, what is my D? So my D in this case is going to be 3. Because remember, it's A2 minus A1, A3 minus A2, and it gives you a common difference of 3. So when we plug it in to find AN, well, AN is 77, A1 is 5, plus N minus 1. We are not sure what N is, and we are multiplying that by 3. So we need to solve for N. Minus 5 from both sides, you get 72 equals 3N minus 1. Okay, and then you're going to divide both sides by 3. Divide both sides by 3, and then you're going to add 1. So that would give me 24 plus 1 is 25. Okay, so 25 is the number of terms in this sequence. So now you have, I'll go all the way down to the bottom, I'm running out of space. So you have S of n is 25 over 2, A1 is 5, AN is 77, and you add them all together, and then multiply, and you get 1,025. Okay, just like that, it's gone. So if you need to go back and rewind it and pause it, go ahead, because I got to finish up with this last one, exercise 5, where Kirk set up a college savings account for his son Maxwell. He deposits $100 per month in an account. Increasing the amount he deposits at 10% per month, how much will be in the account after 10 years? So my A1 is 100. Okay, that's what he put in the beginning. Increasing the deposits 10 per month. So my D is $10. And it goes per month. So we're talking about 10 years. So my N is going to be 120. So there's 120 months in 10 years. So we need to find our A of 120. So A of 120 is 100 plus 119 times 10. Because 119 is your 120 minus 1. So A of 120 is 1290. So that's A of 120. So this is after 10 years. So we need to find the sum of 120. So that means it's 120 over 2 times A1, which is 100, plus A120 is 1290. Again, put that all in your calculator, and you get 83,400. Okay? Pretty nice guy. He's going to have that much money for his kid after 10 years. So, all right. And if there's anything that you need to rewind and play again or whatever, okay, you can rewind it. If you have any questions, make sure you ask me in class. Otherwise, I'll see you in class.